We'll start by explaining one sample mean's confidence interval. Step 1 is the checks. The first check is the independence assumption. The second check would be randomization. The third check is the 10% condition, and the fourth check is the nearly normal condition. Now, for the nearly normal, if your sample size is less than 15, it means it's unimodal, symmetrical, no outliers, and no skewness. If your sample size is between 15 and 30, it means it's unimodal and symmetrical. If your sample size is greater than 30, it means it always checks out unless it's highly skewed. After our checks check out, we would write our sentence that consists of, since my checks for inference are confirmed, I can run a one-sample t interval. The next step would be to write the skeleton formula for the confidence interval. The skeleton formula is y bar plus or minus t star of n minus 1, the standard deviation over the square root of n. Really, it's just t int in the calculator. Now, t star of n minus 1 is actually int of t, which is the confidence interval, plus half of the leftover, and the degrees of freedom, which is n minus 1. The last and final part of our confidence interval would be to write the sentence, which consists of, I am blank percent, which is the confidence level, confident that the true mean, because it's a one-sample mean, of blank, which is your population that you'll have from your problem, is between blank and blank, which are the confidence intervals that you'll get from your skeleton.
Now, the first step for the one-sample mean hypothesis test is to define the HO, or the null, and it is mu is equal to mu of 0. And the HA, or the alternative, is mu is either greater than, less than, or not equal to mu of base 0. The next step is the checks for the one-sample mean hypothesis test. However, we forgot to switch the title, so we have the same pictures as before. First check is independence assumption, second is randomization, and third is 10% condition. The fourth is nearly normal condition, and if n is less than 15, it needs to be unimodal, symmetrical, no outliers, and no skewness. If n is between 15 and 30, it needs to be unimodal and symmetrical. If n is greater than or equal to 30, it always checks out unless the data is highly skewed. After the checks are confirmed, we write the sentence, since my checks for inference are confirmed, I can now run a one-sample t-test. Next, we write the skeleton formula, which is Tn-1 is equal to y bar minus mu 0 over s, which is over the square root of n. Tn-1 is equal to TCDF of the lower bound, upper bound, and degrees of freedom. Use t-test in the calculator.
The last and final step is to write the sentence. Since my p-value of blank, which will be your answer, is blank, which can be greater or less than, my significance level of alpha equals 0.05, I will blank my null. You can reject or fail to reject, meaning there is or is not sufficient evidence to conclude that the true mean blank is blank Now let's try it with a real-life example.
This is Tierney, and she's really lonely. Tierney believes that she was late to the dating game because in middle school she only had one boyfriend. Griffin would like you all to know that he's not actually Tierney's boyfriend. But after thinking and thinking, Tierney finally realizes that this might be actually common, and she gets an idea. She randomly sampled 42 Rancho Mirage High School girls and found out how many boyfriends that they had in middle school. Tierney found out that the mean number of boyfriends in middle school for Rancho Mirage female students is 2.8 boyfriends, and the standard deviation is 0.925 boyfriends. Create a 96% confidence interval and a hypothesis test to see if RMHS female students had only one boyfriend in middle school. The first check we have is independence. Yes, we do have independence because in RMHS, female students' number of boyfriend in middle school is independent of another RMHS female students' number of boyfriends in middle school.
The next check would be randomization, and yes, we do have it because it was given that Tierney randomly surveyed 42 Rancho Mirage High School females.
Next is 10% condition, and yes, it does check out because there is more than 420 female RMHS students.
The last check is the nearly normal condition, and with the rules that we stated earlier in this video, since our sample size is greater than 30, it does check out.
Now that our checks are confirmed, we write, since my conditions for inference check out, I can run a one sample T int.
The next step is to write the skeleton, which is y bar plus or minus t of n minus 1 of s over the square root of n. Now we plug in our numbers and we have 2.8 plus or minus int of t of 98 and 41, 0.925 over the square root of 42. We then get our confidence interval of 2.4972, 3.1028. We then write our sentence, which is, I am 96% confident that the true mean of number of boyfriends that female RMHS students have had in middle school is between 2.4972 and 3.1028 boyfriends. We now can move on to our hypothesis test.
So our null is mu is equal to 1, and our alternative is mu is greater than 1.
The next one is our checks, and although it does say confidence interval, we are doing a hypothesis test. However, the checks are the same, and we are both tired, Gianna, Griffin, and I, and we've decided that we are just going to copy and paste our previous slides, because why do extra work when you already did it? So we're just going to pretend all together that up at the top it says hypothesis test instead of confidence interval, because I know you all have our backs and we really, really, really want and need A's on this presentation.
And notice how Tierney said both, but it's really
All three of us.
Since my checks are confirmed, we write, since my checks for inference are confirmed, I can run a one sample T test.
The next step will be write our skeleton, which is t of n minus 1 is equal to y bar minus mu of 0 over the standard deviation over the square root of n. When we plug in our numbers, we have t of 42 minus 1 equals 2.8 minus 1 over 0.925 over the square root of 42, which equals 12.61. Our p-value then turns out to be 5.32 times 10 to the negative 16th power.
We can now conclude that with the sentence, since my p-value of 5.35 times 10 to the negative 16th power is less than my significance level of alpha is equal to 0.05, I will reject my null, meaning there is sufficient evidence to conclude that female students at RMHS have had more than one boyfriend in middle school.
I guess all my surveying was for nothing, and according to my data, I guess it is uncommon to have only one boyfriend in middle school. I guess I am really, truly lonely.